All right, so good morning. We will do this question on a certain topic. It's a mystery. What is the topic? I have not shown any numbers. I have not drawn any particular diagram except this graph. And the first thing I want you to do is to identify this graph if you can. Okay, it is from one of the topics you study in class 11. Very important topic for Neet, JEE mains, and any exam, AP Physics, IB board, etc. Right? So just in case you have not been able to identify this graph, it's a very popular graph, and it is essentially to do with a spring, okay, a spring which is connected to a mass, and then you keep on increasing the mass, and because of the increase in mass, what you get is extension of the spring. Okay, so this is the extension of the spring. So this was the mass X, you increase the mass, and now you see a certain level of extension, right? So I hope you are able to identify this graph. This graph is basically the force, okay, versus extension graph. Okay, so this is force versus extension graph in x meters. This is in newtons, right? And I have made a spot here. If you notice, this is a dot. What does this dot represent as for you, right? This is called as what? So if you remember your Hooke's law, you remember elasticity and drawing a graph. This is the point which is called as the point of limit of proportionality. Limit of proportionality. Now, this is one of the most important topics, the limit of proportionality, because as you keep on increasing the weight here on the spring, the extension which you get, so every time you put a weight, you get an extension. You put another weight, you get some other extension, and then you put another weight, this is another extension to a certain limit. This is what happens, which is you get a straight line, direct proportionality. So the force is proportional to the extension. I can write this as delta x or x. That's my choice. I choose x here. So this is f is proportional to extension. This is your extension. And this is a straight line, so f is equal to kx, right? Which means k is the slope of this graph, right? So this is your slope k, popularly also known as spring constant, right? So this is your spring constant, spring constant. And you can see the straight line, right? It's a straight line like a y is equal to mx, right? So you should have this conceptualization in your mind as to what is the limit, to which you can go and follow this Hooke's law. You remember Hooke's law, right? So this is all about Hooke's law. Now I'm going to do some numerical on this. We will solve a problem, and it's going to be a bit tricky when we solve this problem. And you will see the value of limit of proportionality there. So when you do straightforward questions, you tend to use Hooke's law, but we will take you in a direction where you will see the applicability of Hooke's law being challenged. And that is the idea, that when you get these questions in NEET examination or your JEE mains examination or AP Physics or IB board or Edexcel or Cambridge, please don't get tempted to use Hooke's law anywhere and everywhere. There's a limit to it, and that limit is dictated by the limit of proportionality, after which the force is not proportional to extension. Okay, it's not a straight line. It takes a curve, and you can mark those points of permanent elasticity, stuff like this. So I'm not. If you want to see the theory behind this curve and the graph, please go to my playlist on mechanical properties. You will see the complete theory of this graph It's a brief introductory video because you have to solve a problem. I just wanted to give you a quick reminder and a revision of Hooke's law. Okay, now let's see the problem. The problem is you have a spring, and you apply a force of 15 newtons to it. And when you do that, the initially it was unextended. When you apply 15 newtons, there is an extension which is there in the spring, and the spring comes to a level. Say the spring now shows a reading of 12 centimeters. So the total length of the spring after so this was without any mass, and now you attach 15 newtons, you get 12 centimeters as the final length of the spring. So this is 12 centimeters. Okay. Now you increase the force to 18 newtons, right? What you find is that the length of the spring is, say, 16 centimeters. Okay? Number one question is, what is the spring constant? What is the spring constant for this? Okay, so you can see that the new force which you applied is 18 newtons, and it resulted in an extension of 4 centimeters. So when you apply F is equal to Kx, right? This is the extension produced by the force. The force is 18 newtons is equal to K multiplied by difference of these two is 4 centimeters, and this is 4 centimeters, and therefore K is equal to 18 divided by 4 by 100. I convert this into 25, and you can multiply 25 into 18, and you get 2,500 plus you get 2000 is equal to 4,500 newtons per meter as your spring constant. Nothing great about this, right? It's a straightforward calculation as to what exactly is happening in this spring. Okay? So there is a change in, I increase the weight, the extension went, so the spring went like this. The spring went down below and it stopped there, and it saw an extension of 4 centimeter. You had 15 newtons here and you had 18 newtons here. This was initially the position of equilibrium here, and this is your new equilibrium position, right? So F is equal to Kx. Now the question is, which is the tricky part. So this was straightforward. F is equal to Kx. Every time you apply a force, you are going to get an extension. Nothing great. And you were conditioned to solve this problem by using F is equal to Kx. And then you can be asked, now the extension is 4 centimeters, right? 5 centimeters. What is the new force which you have applied? Suppose x is equal to 5 centimeter, which is the extension, the delta x. You know the k already from the previous part, and you can find the force. But here is a question now. Now you increase the force to 100 newtons, right? What happens if you increase the force to 100 newtons? That's a tricky part of this question. Okay, why do I call it tricky? Because see, I know that any spring which is given to me has a limit of proportionality. Though I am tempted to use 100 is equal to K, which is 18. Okay, we calculated 4,500. 4,500 into X. And I'm tempted to say that if I apply 100 newtons, I'm going to get 4,500, and I can convert it to centimeters. I will get these many centimeters of extension. Now I'm very tempted to say this. F is equal to Kx. But remember, I cannot say this. When the force is such a large force, we have to be very careful in applying the concept of limit of proportionality. In the question, it is not given whether this force of 100 newtons lies within the limit of proportionality, but I can always comment. My comment and the answer is, if this force is in the limit of proportionality region, I can use F is equal to Kx. However, if the force is outside the limit of proportionality, which is here, I cannot say that F is equal to Kx, which is the direct proportionality may not exist. This is the point I want to hammer. Do not apply F is equal to Kx blindly, because in certain questions, there may be some range given to X where the force and the extension relationship may not be linearly linked to each other. Be very careful on this. So this was to put in your mind the Hooke's law very clearly. The linear relationship is very important, and therefore at very large forces, there is a good possibility that the proportionality limit gets exceeded. And that is why this question. I hope you like this question. If you did, please subscribe to this channel. You will see some quality numericals being solved in this channel. I teach physics and mathematics for class 11th and 12th, which is A level and AS level, O level for the students in CIE or Edexcel or Pearson. And I also teach for JEE mains and Neet examination. And I also teach for AP physics and mathematics. So if you have any questions you want to reach out to me, my number is given in this description box. Please feel free to reach out to me on WhatsApp if you want to, get into details of physics and you want to learn physics. Thank you very much for your time today. And don't forget to subscribe. This channel is known for explanation and deep commitment towards the process of conceptualization. Thank you very much today.